Since time immemorial, man has pondered the contribution of amateur astronomers and their role in contributing to science.
Greetings, I'm David Dickinson from Western Governors University, and I would like to talk to you today about amateur astronomers and their contributions to science. Now, an amateur can be defined as someone that's a novice, but it can also be defined as someone that has a love or passion for what they do. Now, amateur astronomy may be one of the oldest of the sciences. There's evidence of Babylonian observations of solar and lunar eclipses, so time goes back that far as what amateurs have been and professionals have been contributing to. Now, there's no real split at the time up till about the Middle Ages, what's defined as an amateur and professional. A lot of professionals did astronomy just as an aside to other fields in science. It wasn't until the time of the discovery of the planet Neptune, which was discovered by a French theoretician named Leverrier entirely through theoretics and without observation, that astronomy really split from observational and theoretical astronomy, and you get the kind of split that you get with amateur and professional astronomy today. Now, amateurs today contribute such fields as variable star observing, nova observing, comet hunting. We have a slide of comet observations and discoveries by amateurs, automated scopes, and professionals over the past 25 years. And asteroid occultations. Here's the example of a path of a shadow of an asteroid occultation passing over the United States. Enough observers get together, this is what results as kind of a profile or shape of the asteroid. Other types of observations that are out there that amateurs do: meteor shower observing, very simple, just going outside, counting how many meteors you see from a particular shower. Discovering such things as near-Earth objects, lunar occultations similar to asteroid occultations. Some observations are really on the cutting edge, such as spectroscopy, gamma ray observing, and discovering exoplanets. The first exoplanet was discovered in 1992, and amateurs can actually discover planets around other stars now, so it's pretty amazing. There are certain pitfalls with modern technology, such as light pollution. Here's the light pollution distribution over northern Maine. This one usually unthought of impact that modern technology has kind of indirectly on amateur astronomers. Now, there's also certain conflict with automated telescopes discovering comets, which is another pitfall out there that amateurs now have to compete with. General public's perceptions of amateur astronomers now, a lot of people don't realize that most professionals and amateurs, increasingly a lot of amateurs aren't looking through the eyepiece. They have robotic scopes, and they're compiling the data remotely. The image of the professional astronomer, pipe in one hand, stopwatch in the other, looking through the eyepiece is really kind of dated now, unfortunately. It's a romantic notion, but not really true to our times. There are certain amateurs that are also professionals that blur the line. There's Clyde Tombaugh, who discovered Pluto. There's Robert Evans, who discovers novae in his spare time. There's David Levy, who discovered Comet Shoemaker-Levy 9. Now, a lot of trends in modern technology, certain types of observatories. This is an example of a dome observatory. This is an example of an unconventional observatory. And this is a slide-off roof and a robotic observatory. Here's my own slide-off roof observatory. Trends that are coming up in astronomy are, there's a lot more what's called distributed computing, where you link a lot of computers together to produce an outcome. Things like searching for gravity waves, discovering comets, searching for extraterrestrial signals piggybacked on other observations. These are things that our professionals, amateurs can do virtually via the web out there. In conclusion, I think that a lot of technology now is actually, there's going to continue to be a trend toward professionals are going to get more advanced, but amateurs are tending to keep pace. And technology, some people see it as a technological arms race, what's going on out there, but I see technology as a great equalizer that might ultimately set amateurs on the same path as professionals. Are there any questions?
Yes, can you speak a little bit about keeping the home observatory affordable? And as a second follow-up question, what can school children do?
I'm glad you asked that. In my own experience of building an observatory basically only has to serve two purposes. It has to shelter the telescope, and it has to leave the telescope set up so you don't have to align it, you don't have to put everything together, assemble it, lug it out. In this capacity, such observatories like we were showing, like my own observatory, plywood floor, sear shed, 9x10 sear shed, and just a little bit of, I'm not the greatest carpenter in the world, but it shelters the scope and it keeps it aligned. Things like we showed the outhouse observatory, again, just a simple shelter that slides back off the observatory. Very affordable. This was only about $500, and that was the biggest cost was the plywood floor and the shed kit itself. And for your second question, there are such things as variable star observing. Meteor showers are very easy. Again, just know your latitude, longitude. Go outside, count how many meteors you see on a clear night, and you've made a scientific observation. Very simple. Something that children in classrooms and teachers can do. Thank you. Are there any other questions? You asked that. Again, as a good rule of thumb, I believe they'll still be valid, but their contributions will maybe be about such technology as adaptive optics and things that professionals have don't usually come into the hands of amateurs till about 5 or 10 years behind that. Robotic telescopes you didn't see in the 90s, now you're starting to see them. So our amateur observations and technology will probably stay about 5 years on par as a good rule of thumb behind what professionals are doing. Are there any other questions? I'm glad you have enthusiasm for the subject. Contributions such as meteor shower observing, aurora, sunspot counting, of course you have to use the proper eye protection, proper equipment, are all things that amateurs can do. Amateurs are even like doing things like observing changes on the moon, on other planets, things that professionals usually are looking at far out things like black holes or quasars. They're not looking in the cosmic backyard, but amateurs still are and can make sizable contributions in that field. Any other questions? Well, thank you for participating in this today, and we'll end our discussion.